So, who are you? What's your role? And who do you work for?
Hey everyone, I'm Graziano and I'm joining you from Italy. I work as a developer relation engineer in Mia Platform, where we are passionate about empowering teams to build their own internal developer platform capable of harmonizing platform engineering, data, and application composition together. Our mission is to help developers create the platform of their dreams with the flexibility and control they need to truly thrive, as we always say, for better development. Beyond my daily job, I'm very active in tech communities, whether that's through speaking at conferences, writing articles for major publication, or contributing to open source. And about open source, I recently joined the Kubernetes organization as an active contributor in the Docs special interest group, helping to improve the documentation and the blog that so many of us rely on every day.
What are three Kubernetes emerging tools that you are keeping an eye on?
The first tool I want to share with you is simple but really effective. It can help you to save money on your cloud bill and also reduce the carbon footprint of your system. It is called KubeGreen. It's basically a small Kubernetes operator that lets you set custom schedules for your workloads. Basically, you can tell your cluster when to sleep and when to wake up certain namespaces. The main use case is for non-production environment, like test or demo setups. They are usually only needed during working hours, okay? But they tend to run 24/7. If we think about it, most of us work around 40 hours a week, while there are 168 hours in a week. So those environments are running 4 times more than necessary. Now, imagine how many of those environments you have: development, test, staging. It adds up quickly. That's a lot of wasted resources and money. Kubergreen help you to stop that waste. It shut down unused workloads automatically outside the working hours, of course, helping you to save both cost and energy, which is good for you, for your budget, and the planet, the ecosystem. The second tool I want to share is one of those must-have in every platform engineer toolbox. It's called Crow, K-R-O. It's a Kubernetes native framework that helps you to create reusable APIs for deploying multiple resources as a single unit. With Crow, you can wrap a Kubernetes deployment and all its dependencies into a single and easy-to-use API. This is super useful for application team who might not be expert in Kubernetes. They can deploy what they need without having to worry about all the underlying details. Crow make this possible throughout something called resource graph definition. This lets you define how custom resources should be expanded into multiple Kubernetes resources automatically. In short, basically, Crow help you to standardize how workloads are deployed, and it uses Kubernetes itself as the platform to enforce those standards. So your team, your application team, get a simple experience, and you keep, as a platform engineer, control over how things are done. Now, for the last tool, I want to talk about if you are in the world of application development, for example, you are probably seeing the rise of AI copilots that help developers to write code using large language models. But if we brought the same idea to platform engineers, what happened? What if we had a sort of AI assistant that could give us site reliability superpowers? Well, this is exactly what makes Kubernetes GPT, K8s GPT. It uses natural language processing to scan your Kubernetes cluster, looking, for example, at logs, events, and other data to help detect and diagnose issues. It acts like a smart assistant that understands what's going wrong and explain it as in a human readable terms. It comes with built-in analyzers that can spot common problems like I don't know, code crashes, service failures, or ingress misconfiguration, and help you to troubleshoot faster and with less digging around with services and Kubernetes configuration.
Now, in terms of we have some questions that we're going to look at based on different podcast episodes that we've recorded, and the first one is related to one that came up with our guest Colleen, and he said there is a fine line between restricting people and empowering them. When you build a central platform, you are codifying the view of one person or group. Now, Graziano, how do you balance standardization with team autonomy in your organization?
Standardization is key to managing cluster and platform effectively, especially when multiple teams are involved into the platform. Okay, it's easier to build something for one team because the perimeter is fewer. If multiple teams are involved into using your platform, is really difficult. It's more difficult. But it's important to remember that the goal isn't to lock developers into a rigid workflow. We want to create a golden path, not golden cages. Okay, a golden path provide a paved, efficient, and opinionated way to deliver software. Is something that helps the developer to move faster in their day-to-day work. For example, offering pre-built CI/CD pipeline templates, standard Helm charts, or Terraform modules can save a lot of time and reduce error into the software delivery cycle. But developers should still have the flexibility to step off the path when they need to. It could be for edge cases or for advanced use cases of the platform. That's why everything should be modular. And not only modular, but also overridable when necessary. When it comes to abstraction, it's all about balance. A well-designed internal developer platform can abstract away infrastructure details like provisioning a database or deploying a service to Kubernetes. But if these abstractions are too rigid or too far removed from reality, developers will either avoid them or they end up to fight against them. You should be abstraction that are based on real needs, not just to build something to use the latest tech, for example. If you create, just for reference, if you create a custom deployment controller, okay, that only your team understand and no one else use it, you have just added maintenance overhead without delivering value to the other teams. Always, you should always validate with the teams you are building for what you are doing. Just to collect all this stuff in one sentence, you have to standardize to create reliable foundation, abstract to reduce the friction, and always be being focused on the developer experience. You and your platform should enable the teams, should enable your internal customers, not constrain them.
Our guest, Stefan, chose KubeVirt over namespace isolation and vCluster because he needed to support privileged workloads and root access. What factors influence your choice of multi-tenancy solutions in Kubernetes?
That's basically good questions because handling a lot of different namespaces, a lot of different namespaces, a lot of different multi-cluster environments could risk into a sort of tool sprawls. And that's not just about to solve the issue of the tools. It's not about choosing the right tool, but using it into the correct context inside the platform and build experience about it. Basically, when I comes into choose the right tool for the right platform, avoiding to risk into the tool sprawling, I approach it in that way. First, I always push for GitOps workflow. It gives the developers a simple and familiar way to request for infrastructure or deploy services using Git, for example. And behind the scenes, the platform takes care of provisioning and enforcing policies. And this is basically a clean interface. Developers get autonomy and platform engineers keep the control over and the consistency over what happened behind the scenes. Second, I like to create reusable and opinionated components, and tool like Crossplane or Terraform let you to define infrastructure building blocks with sensible default and security baked in. So instead of exposing raw cloud resources, for example, we can give developers high-level building blocks like databases or service cluster that are easy to use and hard to misuse. And then I'm a big fan of developer self-service, and using a developer portal, we can give the teams a UI where they can request things like new environment or services without having to open tickets or dig into YAML, for example. This reduces the friction and keeps the velocity of the team high while the platform still does all the heavy lifting behind the scenes. Last, I suggest, of course, to treat the platform like a product. This means documenting everything well, communicating clearly, and collecting feedback regularly. It's not enough to build something technically advanced. If no one uses it, it's basically a waste. So I always try to talk to developers, understand what they really need and what's getting in their way. And finally, I try to measure the adoption. If the tools and the processes we put in place are being used, that's a signal we need to improve. And maybe we are too complex, or maybe we are solving raw problems, and taking usage, tracking usage, help us to stay aligned with the teams we are supporting.
So Angel expressed interest in Crossplane for bridging the gap between platform users and owners.
Okay.
What tools or practices do you recommend for bridging the gap between developers and platform engineers?
Oh yeah, I totally agree. Crossplane is a great example of a tool that help to close the gap between platform engineers and developers. But it's not just about picking the right tool, it's also about how you build the experience around it. Here is how I approach it when building a platform for multiple teams. First, I always push for a GitOps workflow. It gives developers a simple, familiar way to request infrastructure or deploy services using Git. Behind the scene, the platform takes care of provisioning and enforcing the policies, and it's clean interfaces where developers get autonomy, and the platform engineers and us as platform engineers can keep the control and consistency over what happens behind the scenes. Second, I like to create reusable and opinionated components inside the platform. Tools like Crossplane or Terraform let you define infrastructure building block with sensible default and security baked in. So instead of exposing raw cloud resources like GKE cluster, we can give developers high-level building block like the database or service cluster that are easy to use and hard to misuse. Third, I'm a big fan of developer self-service, and using a developer portal, we can give the teams a UI where they can request things like new environments or services without having to, for example, open tickets to the ops team or dig into complex YAML files. This reduces friction and keep the velocity of the team high. While the platform while the platform still does all the heavy lifting, all the huge work behind the scenes. Okay, it basically reduce the cognitive load for the developers. Fourth, I suggest to treat the platform like a product. This means to document everything well and communicating clearly and collect all the feedback you can gain from your internal customers regularly. It's not enough to build something technically advanced. If no one uses it, it's a waste. Just to do a metaphor, think about the platform like a kitchen, okay? You can build the best kitchen in the world with the best kitchenware available, but if you forget to invite and train the cook to the chef to cook, it's a waste of time, resources, and money. So I always recommend to talk with the developers and understand what they really need and what's getting their way. And finally, I try to measure adoption. KPIs in platform engineering are really, if the tools and processes we put in places aren't being used by the developers, that's a signal that we need to improve or to pivot to another way. Maybe we are too complex, or maybe we are solving the wrong problem. Tracking usage help us to stay aligned with what the teams are needed and what we are providing them to support them.
Kubernetes turned 10 years old last year. What should we expect in the next 10 years to come? What do you think's on the radar? What kind of technologies do you think we can see integrating with Kubernetes?
Kubernetes has come a long way in its first 10 years, from being seen as just a container orchestration tool to becoming the backbone of modern cloud native infrastructure. But as it measures, the next 10 years won't be, I think, about reinventing the core of the tool. It will be more about refining the developer experience, simplifying the operation, and making Kubernetes feel like invisible. One shift is already happening, which is the rise of IDPs, the internal developer platform, on top of Kubernetes. Instead of making every engineers learn how to write YAML or understand, for example, the clusters internals, we are seeing more and more companies adopting IDPs to give the developers a simple interface to interact with these complex tools like the Kubernetes clusters. Kubernetes becomes the plumbing behind the scenes, while developers interact with higher level abstraction that maps to their use cases. Okay, we will also likely to see infrastructure becoming more programmable and policy driven by default. We will also likely to see tools like Crossplane and Open Policy Agents that are early scenes of this trend. Infrastructure will look more and more like APIs. Will look more secure, governed, and managed declarative. Okay, that means platform team will spend less time on ticket-based work and more time building reusable components and guardrails that scale across different teams in the organization. And of course, AI will play a big role, especially around observability or optimization and auto-scaling. Instead of just monitoring metrics and setting threshold manually, we will likely see smarter system that can detect anomalies, suggest right sizing changes, or even fix issues proactively. The SRE model will evolve from reactive firefighting to a proactive tuning, okay? And at the same time, the entire ecosystem will need to take all this complexity. One of the biggest criticism of Kubernetes today is how steep the learning curve still is after 10 years. So we can expect better tooling, more opinionated frameworks, and maybe even lighter alternatives for simple use cases. Overall, Kubernetes is probably going to, let me say, fade into the background. Still critical, still powerful, but less visible. Just to do another metaphor, just like we don't think about how much about how the operating system on our PC or on our MacBooks manage the memory anymore, Kubernetes will become part of the infrastructure fabric, with the focus shifting to developer experience and the business value built on top of it, instead of the complexity and the raw internal of the tool.
And looking at the future in your case, what's next for you?
Oh yeah, we are actually working on this right now. On Mia platform, we have recently started evolving our product into an AI native developer platform foundation. The idea is to explore how AI and generative AI, especially models, can be applied to internal developer platform to drastically improve the developer experience. We are trying to rethink the software development life cycle as we know it today, by combining the power of AI with the context that platform are able to provide. Okay, we all know how useful tools like GitHub Copilot can be when it comes to writing code. Now imagine it and expanding the same kind of support to the entire platform. For example, just to give you some references, we can use AI to help the developers discover and understand the platform components. We can use the AI to get insight on how application on how to use and connect these components. We can use the AI to debug the deployed services and to analyze the observability data to detect, for example, early signals of application degradation before it actually becomes real issues. Okay, it's a more productive way to intend the observability stuff. The goal is to turn the platform into an intelligent companion, okay? One that not only help developers to move faster, but also make their work easier, more reliable, and more enjoyable too. We believe this is the next step in platform engineering, and it's something we are really excited to build.
Last but not least, how can people get in touch with you?
Feel free to reach out to me on LinkedIn, GitHub, or the CNCF Slack. Just search for my name and start the conversation with a simple hey. I'm also often attending industry conferences and events across Europe and the US. So if you see me around, don't hesitate to stop me and say hi. I'd be more than happy to chat.